Hello, Liquid Galaxy team. Welcome to the session on using region based KML to control visibility in Liquid Galaxy. My name is SahanaKB, a BTech Computer Science AI/ML student, and this video is my submission for task 3 of GSoC 2026 prerequisite tasks. So, before we get into the technical details, I want to briefly set the context for this talk. Liquid Galaxy is not just another map visualization platform. It is highly immersive multi-screen system designed to tell stories using geospatial data. Because of this, how information appears is as important as what information appears. In this presentation, I will walk you through why visibility control is critical in Liquid Galaxy, what region-based KML actually is, how it works internally with zoom levels, and how it helps us build clean, scalable, and professional visualization, especially for large or multi-screen setups. By the end of this talk, you should have a clear mental model of when, why, and how to use region based KML effectively. Why visibility control matters. Liquid Galaxy displays geographic content across multiple large screens, creating a very immersive and engaging experience. However, this strength can also become a challenge because the display area is so large, the human eye is exposed to a lot of information at once. If we are not careful about what we show, the visualization can quickly become overwhelming instead of informative. Informations like uh, country borders, city labels, descriptions, overlays, all at the same time instead of helping this audience understand the data. This creates a lot of confusion. Visibility control helps us solve this problem. It allows us to decide what information is important right now, what information can wait until the user zooms in, and what information should remain hidden unless it becomes relevant. This is especially important in presentations, demos, storytelling, scenarios, whatever, wherever, where the audience should naturally follow the narrative without being distracted. Problem without visibility control. Now, let's look at what happens if visibility control is not used. In basic KML files, without regions, all place marks, labels, overlays are rendered at the same time, regardless of zoom levels. This leads to several problems. Labels overlap each other. Important place marks get buried under the less important ones. The screen becomes visually noisy. And in a multi-screen Liquid Galaxy setup, this issue becomes even more noticeable because the content spans across several displays instead of telling a clear geographic story. The visualization feels cluttered and difficult to follow. This is a very common issue, especially when working with large data sets, automatically generated KML files, or beginner level visualizations. Like region based KML exists especially to solve this problem in a structured and scalable way. What is region-based KML? Region-based KML is a feature that allows KML content to appear or disappear based on the visible geographic area and the current zoom level. Instead of displaying everything all the time, we define rules that say show this content only when zoomed in and hide it when zoomed out. This allows us to create layered visualizations. At higher zoom levels, we show less details. As the camera zooms in, the more detailed information is gradually revealed. This approach mirrors how human naturally explore maps and spatial data, making the experience feel intuitive and smooth. For Liquid Galaxy, where storytelling and clarity are crucial, this makes region based KML an extremely powerful tool. Key components of a region. A region in KML is mainly defined using two core components. First component is geographic area. It tells Google Earth where the content belongs. It defines a bounding box using latitudes and longitude values. The second component is level of details, also known as LOD. LOD defines when the content should appear based on the zoom levels. It specifies a minimum zoom level, a maximum zoom level. Only when the camera zoom falls within this range will the content becomes visible. By combining geographic boundaries with LOD rules, we get a very precise control over content visibility. This is a core concept, so it's important to understand it clearly. You can think of it as saying this content exists in this area, but only becomes relevant at this level of detail. Region based KML in Liquid Galaxy. Liquid Galaxy uses Google Earth as its rendering engine, which means it follows standard KML rules, including regions and LOD. Once regions are defined correctly, content automatically appears when zoomed in. Content disappears when zoomed out. No manual toggling or scripting is required. This automation is extremely valuable. Not only does it improve visual clarity, but it also improves performance. Liquid Galaxy does not need to render unnecessary elements when they are not visible. This becomes especially important when working with large data sets, high resolution place marks, or multiple layers of geographic information. Simple use case example. Let's look at a simple and intuitive use case. Region based visibility it can be used to display information in layers. World level data, city level data, and landmark level data. At the world level data, it makes sense to show only the country level information. As we zoom in into the country, city level information becomes relevant. Zooming further reveals landmarks, buildings, or detailed place marks. As you can see the difference. Yeah, this layered approach guides the audience naturally through the data without overwhelming them. Region based KML makes this behavior possible without complex logic or user interaction. Demo overview. And now let's move to the very simple demo. In this demo, I'll show two place marks. One is always visible regardless of zoom level. The second one is controlled using the region, meaning it appears only when zoomed in. The goal here is clarity, not complexity. This minimal setup makes it very easy to observe and understand how region-based visibility works in Liquid Galaxy. Before I play the demo video, let me explain what you're about to see. In this setup, one place mark is always visible, the other one is controlled using a region and LOD. When the camera is zoomed out, only the main place mark is visible. This keeps the global view clean and uncluttered. Now, as the camera zooms in, the second place mark appears automatically. There's no manual trigger, no button, no user interaction. This visibility change happens purely because the zoom level entered the defined region range. What's important to notice here is how smooth this transition is. There's no flicker, no sudden overload of information, no confusion for the viewers. This behavior becomes extremely valuable when working with real world data sets. Instead of loading everything at once, Liquid Galaxy renders only what is needed at that zoom level. In practical scenarios, this technique can be used to show cities only when zoomed in into a country, display landmarks only at street level views, reduce performance overheard in large KML files. Even though this demo is simple, the same logic scale very well to complex and professional visualizations. Benefits of region based KML. From the demo, we can clearly connect region based KML to its benefits. Cleaner visuals come from showing only relevant content, better audience focus comes from reduced clutter, improved performance comes from loading fewer elements at a time. This combination is exactly what makes region based KML a best practice for professional liquid galaxy presentations. Common mistakes. A very common mistakes is assuming region uh, will work perfectly fine without testing it. Sometimes content never appears. Not because the region is broken, but because the zoom range is incorrect. Another common issue is defining regions that are too small or overlapping exclusively. This makes behavior unpredictable and hard to debug. These mistakes are easy to avoid with gradual testing and careful planning. Best practice. The best approach when working with regions is to start simple. Define one region, test it, observe the behavior, then slowly build complexity. It's something like start from the scratch and then move on to what's next. Test zoom levels gradually instead of jumping too far in or out. Also, keeping KML files well organized makes debugging much easier, especially in large projects. When not to use regions. It's also important to know when not to use regions. Um, if the data set is small or the visualization is static, regions may add unnecessary complexity. In such cases, simpler KML structures are often more effective and easier to maintain. To summarize everything we discussed today, uh, region based CAML allows visibility control based on zoom levels. So, when you're zoomed out, less details are shown, and when you zoom in, the details pop up, but not immediately and not all details at the same time. It pop up slowly, and it's you can see the details in well mannered way. It helps manage complex visual data efficiently. It improves clarity, performance, and presentation quality. And it is especially useful in multi screen liquid galaxy environments. Um, Thank you for watching this presentation. If you have any questions or would like to discuss this topic further, feel free to ask it in the community chat and I'll be happy to respond and continue the discussion. Thank you so much.